So for question 9, it's using largely the GDC. So the first part is that we have to sketch that graph onto the axis in the question. And you'll notice that the graph that they're asking you to draw has these straight lines, which are the modulus function, or the absolute value. So to do this one, we're going to go to the GDC and open up a graphing page. And then to find the absolute value, we need to plot those absolute value lines, or the modulus brackets. And to do that, we type A, B, S. And then we open a bracket and we put everything inside that we want the absolute value to be. So x cubed minus 1 over x. So I can use the fraction part, and it's 1 over x. So that's the graph that I'm going to be drawing. And you'll notice it says we need to sketch it between the values of x minus 1.5 and 1.5. So I'm just going to double click the ends of my brackets and change them to those same numbers, minus 1.5 and 1.5. And now I'm going to do the same on the y-axis, so minus 5 and 5. And this just makes it a little bit easier when I'm drawing it onto the axis in the graph paper, in the exam paper, because it means that I'm looking at the same thing, so I can draw it a little bit easier to scale. Now I'm also wondering what these values here are, where it crosses the axis, because that's going to make it a little bit more accurate when I draw. So if I do analyze graph and 0, so it crosses there at minus 1, and I could do the same the other side. Looks pretty symmetrical. Yep, there we go. Another value, which is 1. So now I can try and draw this in. So it comes down, hits at 1, and then goes up. And it's pretty symmetrical. So it looks something like that. And the next part asks me to write down the equation of the asymptote on the graph. So to find the asymptote, it doesn't look like there's a y1, and it's only asking me for 1. So I'm going to look for an x asymptote, and I can do Control T to find my table. And I'm looking for a value that says undefined. So it doesn't seem to be there. There we go. X is 0, is undefined. So my asymptote is x is equal to 0. So to get rid of the table, Control T, and it goes. Then I need to solve the equation for f of x is equal to 2 for the values between minus 1.5 and 0. So that means that I'm only looking at the negative part of my graph here. So I'm only looking at this side of my graph, and I want to find the answer when f of x is equal to 2. So what I'm going to need to do is draw on the line 2, or y equals 2, f of x equals 2. We know that f of x and y mean the same thing in this respect. And then I'm looking for the solutions, which are there and there. So to draw the extra line, I press tab and y is equal to 2. And I'm looking for those intersections. So menu, analyze graph, and intersection. I've got one over here. Menu, analyze graph, intersection. And I've got another one there. So I've got those 2 values. So I can now write down that I have minus 1.4, and I should probably put the 0 so that it's 3 significant figure, and minus 0.475. Okay, I don't need the y coordinate because that's the value of 2. I'm just asked for the x coordinate. Then I need to solve the inequality, which is f of x plus x squared is less than 2. So to do this, the f of x has now had x squared added to it. So that graph is x cubed minus 1 over x plus x squared, and that is less than or equal to 2. So I can plot this graph, and then I can plot 2, and I can find where the graph is less than it. So I'm going to open up a new graphing page, and again it's the absolute value of x cubed minus 1 over x plus x squared. So this time the graph looks like this, and again let's just quickly change the axis. Okay, there's the axis done, and I want to know when is it less than or equal to 2. So I'm going to draw the line of 2, and then I want everywhere that the graph is less than 2, which is in between these two values and then in between these two values. So I'm going to end up with like 2 regions that I'm drawing on. So I need to find those intersections. So I'm just going to do this for every place. So the region where x is less than or equal to 2, if we look at it on the original graph, is almost these places and these places. So if I was to write that, it would be 2 inequalities. The first one is where x is in between, and it can be equal to, because it could be equal to in the question, minus 1.15 and minus 0.536, and then we've also got 0.536 and 1.15. So my answer there is this part with the 2 inequalities.